In every single electrical system, whether it's a small motor or a massive ship generator, there's this silent threat lurking. It's an invisible breakdown that can lead to total, catastrophic failure. But what if you could actually see that threat before it strikes? Well, it turns out there's a tool for that.
So here's what we're going to cover. We'll start by uncovering that invisible threat. Then we'll introduce the tool built to find it, the Megger. We're going to dive into the science of how it works, figure out how to read its results, see what can affect those readings, and most importantly, how to use it safely.
All right, first things first. Let's really dig into the problem we're actually trying to solve here. And this isn't just some theoretical question, The answer to this is the entire reason this tool even exists. We're talking about a fault that gives you almost zero warning until it's way too late. The culprit, the big bad guy here, is failing insulation. See, when that protective insulation starts to break down, it allows for something called leakage current. Basically, electricity escaping where it absolutely should not be. And that can lead straight to short circuits, which can completely fry expensive equipment and, way more importantly, create huge safety hazards for anybody working nearby.
So how in the world do you fight an enemy you can't even see? Well, you need a very special kind of detector. So let's meet the hero of our story.
An insulation resistance tester, which pretty much everyone just calls a Megger, that's a brand name that totally stuck, is designed to do one job, and do it incredibly well. It checks the health of electrical insulation. And it does this by sending a very high DC voltage through it and then measuring the resistance in millions of ohms, or what we call megaohms.
And we're not just talking about small stuff here. We are talking about the heavy hitters, the critical cables running through an entire facility, the windings inside powerful motors, shipboard generators, transformers, and the giant switchboards that control everything. This thing is an absolutely essential tool for preventative maintenance.
Okay, so how does this device actually see the invisible? How does it peer inside an electrical system and check its health? Well, the science behind it is actually surprisingly straightforward.
It really just boils down to a simple three-step process. First, the Megger applies a controlled, high DC voltage. Second, it measures the incredibly tiny amount of leakage current that actually makes it through the insulation. If the insulation is healthy, almost nothing gets through. Finally, it uses that data to calculate the resistance.
And if you remember anything from science class, this is a perfect example of a fundamental principle, Ohm's law. Resistance equals voltage divided by current. So think about it. If the Megger applies a really high voltage but measures a super tiny current, the math tells you that the resistance must be incredibly high. And in this game, high resistance is exactly what you want to see.
Now, you can't just use the same test voltage for everything. It's not one size fits all. The voltage you use has to be scaled to the equipment's rating. So a small circuit might get tested with 250 volts, but some serious high voltage equipment, that might need up to 5,000 volts to really put its insulation to the test.
All right, so you've run the test. The Megger spits out a number in megaohms. But what does that number actually tell you? What's the story it's trying to tell?
This is the million-dollar question, isn't it? Is your equipment safe to run? Does it need to be put on a watch list? Or is it basically a ticking time bomb?
This is where we translate those raw numbers into simple, clear instructions. Anything over 100 megaohms, that's excellent. You're in great shape. Between 10 and 100, still good. You're safe to operate. But once you dip below 10, you really need to start paying close attention. And if you get a reading below 0.1 megaohms, that piece of equipment is dangerous. Do not operate it.
Okay, now I want you to lock this number in your head. 2 megaohms. It's a key part of a really handy shortcut.
There's this great rule of thumb you can use for a quick check in the field. The bare minimum acceptable resistance is 1 megaohm for every 1,000 volts of operating voltage, plus an extra 1 megaohm just for a safety buffer. So for a 1,000 volt or 1 kV system, the absolute lowest reading you'd ever want to see is 2 megaohms.
But here's the thing. A reading isn't just a number in a vacuum. The real world has a way of influencing your results, and you've got to be aware of what's going on with the equipment's environment. A bunch of different things can mess with your reading and make it look lower than it is. For example, higher temperatures can make insulation a little less resistive. Moisture and humidity are a big one. They give current an easy path to leak out. And of course, the physical condition is huge. Old, dirty, or damaged insulation is just not going to perform well. It's so important to think about these conditions when you're looking at your results.
Okay, we've been talking a lot about applying high voltages to equipment, so this next part is critical.
Safety isn't just a suggestion. It is absolutely non-negotiable.
Let's be crystal clear about this. This instrument is specifically designed to generate potentially lethal voltages. You have got to treat it with the respect it deserves every single time you pick it up.
These steps right here, they're your lifeline. First, always make sure the equipment is completely disconnected from its power source, de-energized. Second, wear your PPE. Third, never ever touch the test leads while the Megger is running. And finally, and this is the one people sometimes forget, you have to discharge the equipment after the test. Cables and windings can hold a charge like a capacitor, and you need to safely ground that charge before you touch anything.
And that really brings us to our final thought. The true power of an insulation resistance tester isn't just finding a fault today. It's all about preventative maintenance. It's about tracking your readings over time so you can spot a problem developing before it becomes a failure. A good reading today is fantastic, but the real question is, are you ready to find that silent threat tomorrow?